of x to the negative 4/5 with respect to x. Okay, and from there, we're going to use x, well, the integral of x to the n dx, which is x to the n plus 1 over n plus 1. So this is going to become negative 4/5 times x to the 2 plus 1 over 2 plus 1 plus x to the negative 4/5 plus 1 over 4/5 plus 1. Oh, plus c. Okay, so this becomes negative 5/4 times x to the 3rd over 3 plus, you make that 5/5.
Would it be negative 4/5 plus 1 for the denominator?
Oh, yep.
Okay.
Thank you. So you have x to the 1/5 over 1/5 plus c. All right, so that gives us, we multiply our 3 and our 4. It's negative 5/12 times x to the 3rd. Multiply numerator and denominator by 5. 5x to the 5th plus c. Yep, and that's your final answer. Yep, to the 1/5. Thank you.
I swear that doggone meeting drained me mentally.
All right, so let's say if we have one, let me pick a good one. Yeah, this is good. I'll add this with the notes. This is a good one here. Let's say if you want to integrate 7 over x squared plus 1 with respect to x. Okay, so here we remember that the integral of 1 over x squared plus 1 with respect to x is equal to arctangent of x plus c. Okay, so all we have to do is get our 7 and bring it down to the front times the integral of 1 over x squared plus 1 with respect to x is just 7 times arctangent of x plus c. All right.
You're supposed to remember that coming out.
Yeah, that's why I gave the extra couple of days.
Just to pull it out of your...
All right, so what if we wanted to integrate 10 times sine of x over cosine squared of x with respect to x?
Take the 10 out.
Yep, we take the 10 out first. So you have 10 times the integral sine of x. And instead of cosine squared x, we can make that cosine of x times cosine of x with respect to x.
Would we be able to pull that constant to for cosine at the bottom, so it would be 10 over cosine x. Well, no, never mind, that's not a constant at that point.
Actually, you're on the right track.
Well, if you could do that, then we would get tangent of x with
Yeah.
respect to
So you have
x.
10, but instead of sine of x over cosine squared, you can make that 1 over cosine of x times sine of x over cosine of x with respect to x. So you weren't too far off. You were in the right direction.
But it isn't a constant technically in that equation since there is
Oh, no, it's not a constant. I mean, you couldn't factor it out, but you, as far as separating it, you were on the right track.
Okay.
Okay, so you have 10 times the integral. Remember, secant is 1 over cosine. Oh, clean that up just a bit. And sine over cosine is tangent with respect to x. Okay, so remember, this integral is secant of x plus c. So you have 10 times secant of x plus c. So sometimes you have to manipulate it a little bit.
Would there have to be parentheses around the secant plus c? Because 10 is still a constant?
You know, you don't have to. Because if you had, even like I say, if you had 10 times secant of x plus some constant, and you did distribute the 10, you have 10 times secant of x plus 10 times some constant, which is just another constant. So that's why you just have the 10 times secant of x plus c.
Okay, I see.
Wait, if you knew what the constant was.
We'll go later. Actually on the, not the next example, but the one immediately after.
But if you if you knew what the constant was, you would put it in parentheses, right?
Well, in the ones we're solving, we're actually solving the constant after we integrate, so you wouldn't have to distribute it then. All right, so we'll do one more and then we'll go to the initial value problem. Okay, I just want to give you an idea in case you run across one that looks like this. So the integral of 17 over 1 minus sine squared of x with respect to x. Okay, now with this one, of course, first thing you do is get rid of the 17. So not get rid of it, but factor it out to the front. That's 1 over 1 minus sine squared of x with respect to x. Okay. So this you have to kind of go back to trig and remember that sine squared of x plus cosine squared of x is equal to 1. Yep, so that means cosine squared of x is equal to 1 minus sine squared of x. So that turns this into 17 times the integral of 1 over cosine squared of x with respect to x. Now, you also remember that 1 over cosine squared of x is equal to secant squared of x. So we have 17 times the integral of secant squared of x with respect to x, which is tangent x. So that's 17 times tangent of x plus c. Once again, you have to kind of manipulate it a little bit. All right. got here. All right, I'll get a few extra examples and put them on in the notes since we're running low on time. I want to get these initial conditions out the way. Okay, so initial conditions are used to find the value of the unknown constant C. Okay, so if you think of it this way, let's say here you have x squared. And let's say here you have x squared plus 3. And here you have some x squared plus 5. If you knew just where one point was, you could figure out which one you were talking about. You could figure out your C. If it's 0, it would be there. So if you had a point right on this graph, then you know your C would equal 3. If your point was here, you know your C would equal 5. So if we give you one point, you can figure out exactly what your C is. Okay, so let's say, for example, let's say we want to solve let's just say solve dy, there we go, dx equals -5 secant squared of x minus 2, where we know y of 2 is equal to -1. And this is actually called your initial condition. Just one point on the graph. And that's what we're going to use to solve for our C value. Okay, so the first thing we do is we integrate both sides. The integral of dy with respect to x, or if you wanted to, you could say the derivative with respect to x of y, because that's going to cancel each other out, equals -5 times the integral of secant squared of x minus 2 with respect to x. Okay, so these two cancel each other out, derivative and the integral. So gives you y is equal to -5 times the integral of secant squared of x minus 2 with respect to x. Now, because the derivative of what's inside here ends up being 1, we end up with y equals -5 times the tangent of x minus 2 plus c. Because the integral of secant squared of x is tangent of x. So the integral of secant squared of x minus 2 is just tangent of x minus 2. All right. So we have what's here. So for our initial condition, y of 2, which equals -1, your x is equal to 2, and you can say your f of x or your y is equal to -1. So I'm not a fan of them using y because we're so used to x's and y's. So that means in this function you're going to replace x with x with 2 and y with -1. Okay, so you have -1 equals -5 times the tangent of 2 minus 2 plus c. Which means you have -1 equals -5 times the tangent of 0 plus c.
So C equals -1?
Yep, c equals -1 because tangent of 0 is equal to 0. So -1 equals c. So all you do is you get that c value and plug it into the integral you just had. So that means that y is equal to -5 tangent of x minus 2 minus 1. Okay, so that's the only time c has an actual value, is when they give you an initial condition. All right, so any questions on that one? All right. Leave that up there for a few minutes. And did everyone sign in? All right. All right, and if you have questions, feel free to hang around and ask. If not, I will see you on Tuesday. And let me make a note that I'm going to find out when the... Oh, let me stop there.